Okay, let's dive into this. Welcome to The Explainer. Today we're looking at a truly monumental technical and financial achievement in the mining sector. Greatland Resources' massive reserve upgrade at the Telfer mine. Now, if you follow the industry, you've definitely seen the headlines. But we aren't just going to look at the top-level numbers today. We're actually going under the hood to unpack the exact science, the precise engineering, and the rigorous data modeling that made this milestone possible. To truly appreciate this massive financial headline, we need to trace the steps from the rock face all the way to the processed gold. We'll start with the 5 million ounce milestone, then look at precision geology and drilling, data integrity and modeling, the engineering of the Telfer mine, optimizing ore processing, and finally, what this means for a multi-decade future. Let's get to it.
Starting right off with Section 1, the 5 million ounce milestone.
The headline figure here is just an absolute standout, 62%. That's how much Greatland's Group ore reserve has grown, hitting a staggering 5.0 million ounces of gold. And honestly, what's wild about this is that just the first phase of their drill program at Telfer single-handedly delivered a 150% increase in the Telfer reserve. We're talking 1.8 million ounces, and that's even after depletion. For anyone tracking the resource sector, this volume of high-confidence rock is literally a game-changer that entirely reshapes the asset's overall value. And this brilliantly illustrates exactly where all that gold is actually sitting. We've got the sprawling West Dome open pit on one side, holding over 90 million tons of reserve, alongside the highly targeted main dome underground. What we're looking at here isn't just geography. It's a secured, multi-year baseload reserve. It practically guarantees the operational lifespan of this massive site for years to come. Moving on to Section 2, Precision Geology and Drilling. So you might be wondering, how exactly did they prove these massive reserves even exist? Well, it all comes down to the sheer volume of geological data being collected, and it is staggering. The updated resource model we're exploring today was compiled from just about the first half of a forecast 240,000-meter drill program for FY26. Just pause and think about that. 240,000 meters of drilling. That is an astonishing amount of core being pulled out of the earth. And remember, the massive reserve upgrades we're discussing, they only account for roughly half of that planned program. But, it's not just about drilling deep. It's about microscopic precision. The contrast here is actually fascinating. You have this gigantic, landscape-altering mine, yet the quality assurance relies on taking 1-meter samples via cone splitters, drying and crushing them, and then pulverizing the rock until 95% of it can pass through a 75-micrometer screen. That is literally finer than a human hair. From there, a precise 30-gram sample gets hit with a high-heat fire assay. This rigorous, microscopic QA/QC journey, that's the bedrock of these billion-dollar estimates. All right, Section 3, Data Integrity and Modeling. Now, what's really interesting here is that in mining, your data is only as good as its compliance. Greatland operates strictly under the JRC Code 2012 edition, so their massive SQL-acquired database isn't just some spreadsheet. It's a heavily regulated, continuously validated vault of geological truth. From direct digital input right at the rigs, all the way to external laboratory audits boasting a 90% repeatability rate, this strict framework guarantees that the 3D models we're about to look at are absolutely rock solid. To actually map the ore body, they build a 3D block model. They start with these large parent blocks, but the technical brilliance really shines in the sub-blocking. They break it down to dimensions of 6.25 by 6.25 by exactly 4 meters. Why 4 meters in height? Because it perfectly matches their selective mining unit, the exact height of the flitches or slices of rock that their diggers carve out. Because the digital math is already perfectly aligned with the physical digging equipment, they need 0 additional dilution factors in their open pit estimates. It's incredibly efficient. And deciding which of those specific blocks gets mined, that relies on the net smelter return, or NSR. You can really think of the NSR as Greatland's superpower algorithm. Instead of just looking at the gold grade, the NSR dynamically calculates the actual payable profit of every single block. It factors in metallurgical recovery, the gold price, processing costs, and logistics. It even adapts dynamically, knowing the break-even cutoff is way lower for an open pit block trucked to the surface compared to an underground block that has to be hoisted up a shaft. This guarantees that energy and money are only spent extracting truly profitable rock. Let's move to Section 4. Engineering the Telfer mine. Now let's bridge that digital model to the actual heavy machinery required to get the rock out of the ground. Telfer essentially runs two drastically different engineering playbooks at the same time. On the surface, the West Dome open pit is an exercise in sprawling, bulk earth moving. We're talking 90.6 million tons of reserve being moved by massive CAT 6060 diggers and CAT 793 trucks working on 12-meter benches. Contrast that with the main dome underground, which is a highly selective, targeted environment. Down there, they use 21-ton loaders, 63-ton trucks, and precision long-hole open-stopping techniques to carefully extract the high-grade reefs from below.
Let's move to and see how this builds visually. We have the sheer footprint of the West Dome open pit shell contrasting with the complex three-dimensional web of the main dome underground. What's super exciting about the underground model is that there's a vertical shaft hoist currently installed there with a capacity of almost 6 million tons per annum, originally built for a historic caving operation. But right now, they are only mining 1 to 1.5 million tons a year underground. That means there is massive underutilized hoisting capacity just sitting there, waiting for future underground expansion. Which brings us to Section 5, Optimizing Ore Processing.
Once the rock is out, Telfer boasts a world-class processing facility capable of chewing through 20 million tons of ore every single year. But it's not a simple machine. It's an elegant, multi-stage scientific recipe designed to handle varying ore hardness and really complex mineralogy. First up, flash flotation and gravity circuits capture the coarse, free gold. Next, a pyrite flotation circuit specifically isolates the copper sulfides. Then, the remaining material heads to a cyanidation leach circuit for final extraction, wrapping up with carbon adsorption and electrowinning to produce the final gold doré and copper concentrate. It is a highly optimized, dual-train system that maximizes every ounce of value from the rock.
And finally, Section 6, a multi-decade future. So we've geeked out over the massive scale, the microscopic precision, the algorithms, and the processing chemistry. What does this all actually mean long-term? Well, the crucial point is this. Everything we've looked at today, that massive 62% jump to 5.0 million ounces, is really just the baseline. As this quote from the operations team outlines, their strategy isn't just about mining what they've already proven. It's about advancing higher-grade opportunities and fully utilizing that 20 million-ton processing capacity to create a multi-decade operational hub, eventually integrating in parallel with the nearby Javier in development. Which leaves us with this really thrilling question to wrap up on. Remember earlier when we talked about that underutilized underground hoisting capacity? Well, this massive 62% reserve growth was achieved without even including the West Dome underground project or the vertical stockwork corridor. Both of those massive underground targets are currently sitting as resources, subject to ongoing studies, and they aren't even in the reserve math yet. So if this is what Greatland can engineer from just the first half of a drill program, what on earth is the math going to look like when the rest of the underground is officially unlocked? It is an incredibly exciting time for mining engineering for sure. Thanks so much for learning with me today.